In this video, I'm going to find the limit of this rational function as x approaches infinity. The function is x cubed plus 3x divided by x to the power 4 plus 7x cubed. If I apply the quotient rule for a limit, we land with a situation where we have infinity over infinity, so that doesn't really help. So what we need to do, we need to apply a simple trick. And the trick involves manipulating this function and expressing it in a way so that it's manageable and we can find the limit. So what we do here is that we take this function and divide it by the highest power of the numerator in this case, because that's the smaller power. So what's going to happen is that we divide the numerator by x cubed and we divide the denominator by x cubed. If we divide it, this is what we get exactly right here. X cubed divided by x cubed is 1. 3x divided by x cubed is 3 over x squared. Similarly, in the denominator, x to the power 4 divided by x cubed is going to give me x, and 7x cubed divided by x cubed is going to be just 7. I think it's just 7, this one. And that means that this is just 7. Now we take the limit of this function, given function f of x, as x approaches infinity, which is this, but this is equivalent to taking the limit of this function. All right. Now let's look at the modified function. What do we get? So if we write it out, which I'm not going to write out in details just to save time, is this. We are going to take the limit of the numerator and the limit of the denominator. Okay. Now the limit of the numerator is going to be just 1. Why? Because limit of 3 over x squared as x approaches infinity is nothing but 0, because x becomes extremely large, x squared becomes even larger, so 3 over x squared goes to 0. So in the numerator, after I evaluate the limit, I'm going to get 1 plus 0. First, I will apply the quotient rule, which will be giving me the limit of the quotient as x approaches infinity, limit of the numerator, and then the limit of the denominator, okay, as x approaches infinity, x approaches infinity. Then I apply the addition rule to break it down into two functions, limit of 1 plus limit of 3 over x squared. Limit of 1 is just 1 and limit of 3 over x squared is just 0. Similarly, in the denominator, I will have limit x approaches infinity x plus limit x approaches infinity, just 7. This is nothing but 7, right? 7. But this is infinity. So infinity plus 7 is infinity. So as a result, the denominator becomes infinity. So any fixed number divided by infinity is nothing but 0. So that means as limit goes to infinity, the whole given function goes towards 0. As x goes towards infinity, this given function, the limit of it as x goes to infinity becomes 0. It pulls the function down to 0. Now, another way you could think of it is this, by the way. This is a polynomial function in the numerator and a polynomial function in the denominator. The highest power of the polynomial function is 3, or the power of this polynomial function is 3, highest power, x to x cubed, and in the denominator, the highest power of x, again, it's a polynomial function, highest power is 4. In the long run, the way this function behaves, or this rational function behaves, is that the highest power dominates. That means x to the power 4 dominates over any other terms, okay? As x goes towards infinity. Consequently, it brings down the entire ratio and it becomes 0. I hope that this discussion was helpful. Thank you very much.